So we're group 105 and we're presenting deFAANG. This is our project which optimizes how you're going to pick certain stocks based on a certain number of inputs that you give as your investment strategy and the stock that you would like to draw correlations from. Let's just get started. We are ready to start the program. Just as a side note, each one of these has input validation. So if I were to put just a random thing, it wouldn't work.
Yeah, so as we're starting the program, we get some CSV files imported into pandas data frames, which are then used to draw to calculate correlations, standard deviations as a measure of risk, and etc. So you have your instructions here telling you to choose from an S&P 500 stock, and that we're going to be allocating a budget in the most optimal way possible. So first, you choose to build up your data structure, a graph as an adjacency matrix or list. So we'll start with a matrix.
It also includes how much time it's going to take you to build each one of these. I built it in 9.3 seconds this time, and we're going to pick just a random budget. Let's do $980. And we're going to pick, as an example, we're going to pick Google, which is with its stock ticker. And we would like to invest in, say, 13 stocks. We would like to invest because we think Google is going to go up and we want to invest in similar stocks and high risk investment strategy.
Yeah. So Mazin can talk about the heaps that we used.
Yeah, so whether you're using an adjacency matrix or list, we have a max heap and a min heap, which they're designed to manage a collection of stocks with associated correlation values and standard deviation. And for the min heap, it is used for stocks that we invest in, and it will return the max n correlated items. And the max heap is the opposite, that if we're shorting a stock that we select, it will return the n least correlated values. And this you will see later on in our investment strategy in the program through dynamic programming, which Thomas will now speak about.
Yes, so before going to dynamic programming, the budget allocation is done based on risk. Because we chose high risk, it's allocating more of our budget into the stocks that have a higher risk index and least of on the ones that have a less risk. And the optimal stock allocation is where we use the dynamic programming knapsack algorithm, and it basically chooses the stocks that are going to maximize risk for you. So in the interest of time, let's just move on.
So with this part, you can choose stocks in your portfolio to compare against the original stock you chose from. So you'd compare against Google. You can choose, I don't know, CTAS or whatever, or MTD, and you see how they move very similarly and therefore are very correlated, which shows exactly how our algorithms are working.
Yes, now that we explained the whole thing, we're going to do one more pass just to show other correlations and the data structures that we used. So this time we're going to start the program.
Yeah, and we use an adjacency list.
Yes, which adjacency list. This is basically the same because we have a fully connected graph. They're going to have very similar build times. In general, if it wasn't a fully connected graph, it would be way faster. So we can choose the same or even more. Let's just choose $1,000. And we would like to draw correlations from Apple. I don't know, 20 stocks. Let's go crazy. And let's short them. So we want opposite behavior. And we can also do high risk or low risk, but let's just do low risk to test the difference. So now it's allocating more of our budget into the stocks with the least risk. Let's just plot one because our time is almost over. And we can choose Navi because it allocated a big portion of our budget into Navi. And as you can see, they're gonna have very different behaviors. This one's staying kind of steady. Navi's staying kind of steady while Apple is consistently growing. So it has a low correlation number. And that's basically all the functionality of our program using the different straight data structures that we mentioned.